Okay, the last section on our linear, exponential, quadratic sequences and functions is you're going to come in, you're going to be given data. We love to look at population because populations can grow in all different ways. As you look at this population, I would hope that you would start looking at the differences. Taking your calculator and subtract. Look for a common difference. And I would actually calculate each one out. What's the common difference? Now, as we get up here, you can just see by line of sight with me for a minute. This one's close to 1,000, 1,005. This one is at almost 2,500. So we have a huge difference in these, at least in this one and this one. You can look at the others there. The common ratio, put it in your calculator and calculate each one. When you do that, this one comes out 6,000 over 5,000 is about 1.2 and about 1.98, 1.18, 1.2, 1.21. Don't take my estimate there, that's just in the back of my head what I'm thinking. Or top of my head, that's what I'm thinking. But you can see the common ratio is much closer. So you should be able to give me a viable argument as to why you feel that this data would be an exponential model. And then you would go through and explain different ways that you could graph it on a scatter plot, find the line of best fit, find or that's the regression, the line of best fit, the regression, and then what the residuals are and what your approximate equation would be. Then you'll do some predicting. Now remember, if you're predicting beyond the data, that's called an extrapolation. And we talked about this in class and maybe on another video, but extrapolation, when it goes beyond your data, those are not as accurate as intrapolation. Intrapolation means that it's within the data points, within the domain that I've given you. Okay? So intrapolation is inside, and those are more accurate than extrapolation for obvious reasons. You've got a line in there, once you've graphed it, that you can say, hey, it should be close to this. And for extrapolation, a lot of times it goes off your line. So be able to explain that as well. You'll come into class and have some scenarios to follow through on that. Thank you.